Hello everyone. Hello everyone, and welcome to the eighth session of the Snowflake Educational Series powered by BluePie. My name is Tanika, and I will be the host for today's session. So, in case you have missed out on the previous sessions, please check them out on our YouTube channel, and you can find the link to the same in the chat box. Now, I'd like to introduce today's speaker, Ayushi Kaushik. She's a senior engineer at BluePie and has experience working with PySpark, ETL, and data warehousing projects. She will be talking about resource monitoring in Snowflake. I hope you guys enjoy the session. Over to you now, Ayushi.
Okay. Thanks, Tanika, for the introduction. A very good afternoon to everyone, and thank you for joining me today. Welcome to the eighth webinar of Snowflake Educational Series powered by BluePie. Just give me a moment to share my screen. Before diving in, I would like to navigate you through the platform. On the right-hand side of your screen, you will see a Q&A tab and a chat section. Please post any questions that you have during the session, and I will pick those up during the Q&A time in the end. Okay. And there is also a chat section where we will be posting some useful links during the session. Okay. So in the previous session, we talked about Snowflake's history and architecture, how it provides high availability and disaster recovery, how we can securely share data using data clean room, and we have also covered how to build data lake and ELT pipelines in Snowflake. So if you have missed those sessions, you can head over to our YouTube channel and find the recordings of those sessions. Those are also available on our LinkedIn page by the name BluePie. In today's session, we will talk about Snowflake's pricing and resource monitoring. We will be discussing the many aspects of Snowflake pricing that one should be aware of before going ahead with the implementation. The pricing philosophy adopted by Snowflake is not very different from that of other popular cloud data warehouse services, such as Amazon Redshift, in that the emphasis is on providing maximum flexibility for the user in terms of usability of the different services provided. Snowflake architecture consists of three major layers: data storage, compute, and cloud services like data transfer and serverless capabilities. So, Snowflake pricing reflects your usage of these distinct layers. Furthermore, you don't pay cash directly for Snowflake resource consumption. Instead, you pay using Snowflake credits. A Snowflake credit is a unit of measure, just like a virtual currency which is consumed only when customer is using resources, such as when a virtual warehouse is running, or maybe the cloud service layer is performing some work, or serverless features are used. Snowflake credits are used to pay for the consumption of resources. Cost of these credits depend on which Snowflake edition you are opting for. Snowflake provide multiple editions to make sure that usage fits into the organization's specific requirements. Each successive edition of the Snowflake builds on the previous editions through the specific features and offers high-level services. The Snowflake edition that your organization chooses determine the unit cost of the credit and the data storage you use. So we have majorly four editions provided by Snowflake. Standard edition, which is the introductory level offering, providing full unlimited access to all of Snowflake's standard features. It provides a strong balance between features, level of support, and cost. Then we have Enterprise Edition. Enterprise Edition provides all the features and services of Standard Edition with additional features designed specifically for the needs of large scale enterprises and organizations. Next is business critical edition, formerly known as enterprise for sensitive data, offers even higher levels of data protection to support the needs of organizations with extremely sensitive data. It includes all the features and services of Enterprise Edition with the addition of enhanced security and data protection. In addition, database failover, failback, adds supports for business continuity and disaster recovery. And last, we have Virtual Private Snowflake. Private Snowflake offers our highest level of security for organizations that have the strictest requirements, such as financial institution and any other large enterprise that collect, analyze, and share highly sensitive data. It includes all the features and services of business critical edition, but in a completely separate Snowflake environment, which is isolated from all other Snowflake accounts. However, you may choose to enable data sharing with non-VPS customers by contacting Snowflake support to enable listing auto-fulfillment. A link will be shared with you in the chat box, which compares the difference in these different features of Snowflake editions. Now that you have an idea as to how the costs are incurred based on the credits accrued depending on the usage of the different Snowflake services, this section talks about the opinions for choosing a pricing plan. There are two ways to buy the Snowflake service: on demand or prepaid capacity, which is also called as pre-purchased capacity. So, on demand, the easiest and most flexible way to purchase these Snowflake services on demand. This is similar to the pay-as-you-go pricing plans of other cloud service providers such as AWS, where you only pay for what you consume. At the end of the month, a bill is generated with the details of usage for that month. Second is pre-purchased capacity. With this option, a customer can purchase a set amount or capacity of Snowflake resources in advance. The major advantage of going with this plan is that the packaged pre-purchase rates will be available at a lower price than the corresponding on-demand option. A popular way of going about the pricing strategy, especially when you are new and unsure about this, is to first opt for the on-demand and then switch to pre-purchase. Once the on-demand cycle starts, monitor the resource usage for a month or two, and once you have a good idea of your monthly data warehousing requirements, switch to a pre-purchase plan to optimize the recurring monthly charges. The pricing depends on the region and preferred platform. We will be dropping another link in the chat box where you can go and explore the different pricing for different regions and different platforms. Now let's try to understand how these credits are consumed. There are four major factors leading to credits consumption: storage, compute, cloud services, and data transfer. Let us first talk about storage. Snowflake bases charges on the daily average data volume in bytes you store in its system. This includes compressed or uncompressed files you stage for bulk unloading or loading, historical data you maintain for file save, and data kept in database tables. Snowflake automatically compresses all the table data so that the actual physical space occupied by these tables is less than their combined row size. It then calculates how much storage an account uses based on this compressed file size. Also, the monthly charge for data storage in Snowflake is set at a flat rate per terabyte. However, the precise amount per terabyte that you pay is based on your type of account, whether it is on demand or pre purchased, your region, and your platform: AWS, Azure, or GCP. Typically, Snowflake charges a minimum of $25 and up to $40 per terabyte of data you store in its US system. The second factor is compute resources. These are a set of servers together called a compute cluster that can carry out operations like query execution and data loading. The build cost of using compute resources is calculated by multiplying the number of consumed credits by the price of a credit. There are three types of compute resources that consume credits within Snowflake. First is virtual warehouse compute. Virtual warehouses are user managed compute resources that consume credits when loading data, executing queries, and performing other DML operations. Credits are billed per second with a 60-second minimum requirement, meaning starting or resuming a suspended warehouse incurs a fee of 1 minute's work or usage. But after a minute's usage, all subsequent usage resumes on a per second billing as long as you run the virtual warehouse continuously. Stopping and restarting warehouses within the first minute leads to multiple charges because the 1 minute minimum charge applies each time you restart or start the warehouse. Also, since Snowflake uses per second billing, warehouses are built only for the credits they actually consume when they are actively working, not when suspended or being idle. In fact, it offers a quick start stop feature to suspend resource usage whenever you choose or automatically with user defined rules such as suspend after 5 minutes of inactivity. Next, we have serverless compute. These are Snowflake features such as search optimization and Snowpipe that use Snowflake managed compute resources rather than virtual warehouses. To minimize cost, these serverless compute resources are automatically resized and scaled up or down by Snowflake as required for each workload. The credits used by these serverless features are not monitored or controlled by resource monitors. Resource monitors only work with the virtual warehouses that you create or manage in your account. Now let us see an example of how virtual warehouses are built. Consider a extra small size warehouse. In a extra small warehouse, 1 hour is charged 1 credit, which means 1 minute will be charged 0.02 credits, which is 1 divided by 60. And 1 second will be charged 0.0003 credits. So after 1 minute of usage, the number of seconds will be multiplied by 0.0003. As you see in the graph, up to 1 minute charge is 0.02 credits. And after that, it depends on the exact number of seconds the warehouse was active. The third factor of Snowflake's pricing is cloud services. The cloud services layer of the Snowflake architecture is a collection of services that coordinate activities across Snowflake. This layer authenticates user, enforces security, performs query compilation and optimization, handles requests, query caching, and more. Cloud services tie together all of the different components of Snowflake, including supporting the use of virtual warehouses. This cloud services layer is constructed of stateless compute resources, running across multiple availability zones and using a highly available distributed metadata store for global state management. Usage of the cloud services layer is charged only if the daily consumption of the cloud services resources exceed 10% of the daily warehouse usage. The charge is calculated daily in the UTC time zone. This ensures that the 10% adjustment is accurately applied each day at the credit price for that day. The adjustment on the monthly usage statement is equal to the sum of these daily calculations. Another factor of Snowflake's pricing is data transfer. Snowflake does not charge data ingress fees to bring data into your account, but it does charge for data egress. Snowflake charges a per byte fee when you transfer data from a Snowflake account into a different region on the same cloud platform. or into a completely different cloud platform. Features such as external tables, external functions, and data lake export or replicating data may incur data transfer charges. This per byte fee for data egress depends on the region where your Snowflake account is hosted. Now let's discuss few things to be kept in mind while we optimize these incurred costs. Depending on your location, it is important to choose the cloud region wisely to minimize latency, to have access to the required set of features, etc. If you are to move your data from a region to a different region later on, there are data transfer costs associated with it at a per terabyte scale. So the larger your data store, the more the cost you will incur while migrating it. Second is it can make quite a difference to the cost incurred by optimally managing the operational status of your compute clusters. The features such as auto suspension and auto resume should be made use of unless there is a better strategy to address this. Next is the workload or data usage monitoring at an account level, warehouse level, database or table level is necessary to make sure that there are no unnecessary query operations or data storage contributing to the overall monthly cost. Make sure to have the data compressed before storage as much as possible. There are instances such as storing database tables where Snowflake automatically does a data compression. However, this is not always the case. So, this is something to be mindful of and to be monitored regularly. Snowflake works better with the date or timestamp columns stored as such rather than them being stored as type var character. Try to make more use of transient tables as they are not maintained in the history tables, which in turn reduces the data storage cost for history tables. Now, enough about Snowflake pricing. Let us move over to resource monitoring. Let me tell you the meaning and definition of resource monitoring, what actually it is, how it works, and its key features. To help control cost and avoid unexpected credit usage caused by running warehouses, Snowflake provides resource monitors. A Snowflake warehouse consumes Snowflake credits while it runs. A resource monitor can be used to monitor credit usage by virtual warehouses and the cloud services needed to support those warehouses. If desired, the warehouse can be suspended when it reaches a credit limit. The number of credits consumed depends on the size of warehouse and how long it runs. Limits can be set for a specified interval or date range. When these limits are reached or are approaching, the resource monitor can trigger various actions, such as sending alert notification or suspending user managed warehouse. Resource monitor can only be created by account administrator, which means your role should be of account admin while creating a resource monitor. However, account administrator can choose to enable users with other roles to view and modify resource monitors using SQL. A resource monitor is a first class object in Snowflake consisting of the following properties: credit quota, monitor level, schedule, and actions. Let us talk about the first property of resource monitor, which is credit quota. Credit quota specifies the number of Snowflake credits allocated to the monitor for the specified frequency interval. Any number can be specified. Second is monitor level. This property specifies whether the resource monitor is used to monitor the credit usage for your entire account, which means all the warehouses in the account, or a specific set of individual warehouses. If this property is not set, the resource monitor does not monitor any credit usage. It simply remains dormant. Next is schedule. The default schedule for a resource monitor specifies it starts monitoring credit usage immediately and the used credit reset back to zero at the beginning of each calendar month. However, you can optionally customize the schedule for a resource monitor using the following properties. Frequency: the interval at which used credits reset relative to the specified start date. Supported values for frequency can be daily, weekly, monthly, or yearly. So the fourth property of resource monitor is actions, also referred to as trigger. Each action specifies a threshold as a percentage of the credit quota for the resource monitor and an action to perform when the threshold is reached within the specified interval. Note that actions support thresholds greater than 100. Resource monitor support following actions: notify and suspend, which means send a notification to all account administrator with notifications enabled, and suspend all assigned warehouses after all statements being executed by the warehouse have completed. Second option is notify and suspend immediately. This will also send a notification to all the account administrator with notification enabled, but this time it will suspend all assigned warehouses immediately, which cancels any statement being executed by the warehouse at that time. Third option is notify. It does not perform any action but send an alert notification to all the account administrator which have enabled their notifications. An important point to note here is that a resource monitor must have at least one action defined. If no actions have been defined, nothing happens when the used credits reach the threshold. Let me tell you about how assignment of resource monitor work, how a resource monitor can be assigned, and other associated options with it. A single monitor can be set at the account level to control credit usage for all warehouses in your account. In addition, a monitor can be assigned to one or a specific warehouse, thereby controlling the credit usage for each assigned warehouse. Note, however, that a warehouse can be assigned to only a single resource monitor below the account level. Based on this diagram that you are seeing in the presentation, the credit quota for the entire account is 5,000 for the interval as controlled by resource monitor 1. If this quota is reached within the interval, the actions defined for the resource monitor, which can be suspend or suspend immediately, are enforced for all 5 warehouses. Warehouse 3 can consume a maximum of 1000 credits within the interval. Warehouse 4 and 5 can consume a maximum combined total of 2500 credits within the interval. How warehouse suspension and resumption works in accordance with resource monitor different actions. I will tell in depth about this mechanism. The used credits for a resource monitor reflects the sum of credits consumed by all assigned warehouses within the specified interval, along with the cloud services used to support those warehouses during the same interval. If a monitor has a suspend or suspend immediately action defined and its used credit reach the threshold for the action, any warehouse assigned to the monitor are suspended and cannot be resumed until one of the condition is met. First condition is the next interval, if any, starts as dictated by the start date for the monitor, or the credit quota for the monitor is increased, or the credit threshold for the suspend action is increased, or the warehouses are no longer assigned to the monitor, or the last condition is the monitor is dropped. Only then the warehouse can be resumed. Now, when a resource monitor reaches the threshold for an action, it generates one of the following notifications based on the action performed. The assigned warehouses will be suspended after all running queries complete. All running queries in the assigned warehouses will be cancelled and the warehouses suspended immediately. A threshold has been reached but no action has been performed. The notification is sent to all account administrators who have enabled receipt of notifications and non-administrator users in the notification list. Notifications can be received by account administrator through the classic web interface or email. However, by default, these notifications are not enabled. To receive notifications, each account administrator must explicitly enable notifications through their preferences in the classic web interface. In addition, if an account administrator chooses to receive email notifications, they must provide a valid email address and verify the address before they will receive any emails. Notifications for non-administrator users are only available through email. So this was it for today's webinar. If you have any questions, please put up in the Q&A box. Okay, so I see there are no questions. We can move on. Um, I hope this session was useful to you. Over to you, Tanika.
So, for any questions or your valuable feedback, please feel free to mail us at the email address that is mentioned on your screen. And also, please follow our channel on YouTube and LinkedIn for regular updates on these sessions. Thanks a lot for joining.